All right, so welcome everyone to SIG On-Prem meeting on 12th of April. We don't have many participants, and this is probably something we need to work on. I might share some feedback after KubeCon. I had endless talks with different people. So what we have on the agenda today is actually the cargo demo by Matthew Masson. Then Jorge Castro suggested starting with fixing documentation on premise. Actually, it doesn't look very good, so we would like to talk about that. And we also want to talk about SIG leadership. So yeah, I think we can start. Oh, and by the way, we're looking for note taker. So anyone happy to take notes during the meeting? Any volunteers? Come on, it doesn't hurt.
I'll take notes.
Okay, great. I was actually looking at you a little bit. Well, that's cool. All right, so Matty, Matt, are you ready to present, or maybe some background for this demo? So there was a plan for different demos, but the guys were not able to deliver today. At the same time, we had demo of cargo, but that was more a digital rebar that is using cargo internally. And people were asking about specific cargo features and development, what's going on there. So I decided just we can do the cargo, and we'll have another demos in 2 weeks probably. So Matthew, are you ready to?
Yeah.
Okay, so check if you can share the screen.
Just want to make sure I can get this window shared. This one. Okay.
Yeah, we can see it. It's a little bit kind of distracting. Oh, that's better now.
Okay. So this is a bit of a rehash. I did give this presentation in Lviv. So there's like 4 ways to say the city in Ukraine back in September, but it's just a little bit updated. Kind of got last minute notice to present, so you'll have to forgive me for not coming up with a new slide theme. So you guys all know what Kubernetes is, so I don't have to explain what Kubernetes is. Kubernetes is about managing containers and networking, applications, and services. Of course, when you're deploying Kubernetes, you need to have some nodes designated different roles. You need masters and then the actual worker nodes. Some people call it minion, some people just call it node. They usually run on Docker runtime, and then you usually want some sort of networking if you're using a multi-node deployment. And then certificates, because certificates aren't automatic. You have to really set them up unless you want to use the automated system in Kube API server or the self-signed one, which I don't really recommend. I got this from Wikicommons, just a little layout, what components you need. You need etcd, you need the API server, controller manager, scheduler, that's master node. You can run more there, but you need that. Plus, it's not listed here, but the actual network plugin runs also on the master because they need to be able to look up internal domains and yeah, that's it. They just need to look up internal domains. The minion nodes run kubelet and kubeproxy as system services generally, or kubeproxy as a static pod, and then you run actual workloads inside. And deployment is incredibly divisive. I've seen a couple of other projects that were turned down for incubation or didn't get enough attention because there's already several in incubator and some that are, how do you say, grandfathered in that are not even active, but that's another story. There's only one official story for deployment, and that's KubeADM. Everyone else is sort of in this gray area, and that's where Cargo fits in as well, and KOps and some others. So there was a salt-based tool that got basically neglected. Deployment is somewhat complicated because you do need to run several commands in a certain order across multiple machines, especially if you're doing multi-master. Not everyone agrees on what tools to use: Puppet, Salt, Chef, Ansible, or something natively written in Golang, which seems to be what the community leans towards more. You can't run everything purely inside of Kubernetes, except for Bootkube, which does require services outside of Kubernetes to begin with. So you do need systemd integration somehow to get everything going in most cases. And the way to do that isn't always agreed upon between different deployers. And then lastly, it's still divisive because KubeADM is still not ready for production. They still don't do upgrades or HA, but that's one of their main goals for 1.7. They didn't want to do it before because they wanted to get more features in before they had to lock down the API and make it more restrictive. So they had good reason not to do it, but now that's going to come to an end. So Cargo is an Ansible playbook. It's not a script. It's not a playbook plus something else. It is an Ansible playbook. You run Ansible playbook command. You point to your inventory. You point to this playbook called cluster.yaml, and that's it. That's what Cargo is. You can set a bunch of options to configure your deployment. For example, if you need to bootstrap your host with Python, you have to specify what OS you're on, because Ansible needs that information explicitly if you don't have Python, or you choose your network plugin, or you choose what version of Kubernetes you want to install. These sort of things are configurable. But it's just a playbook. One big benefit that we got a lot of feedback from the community is that it's readable. So maybe it's not the fastest approach. It doesn't get everything done in just like 2-3 minutes, but it's very readable. You can figure out what's going on and figure out why it's failed very quickly, because Ansible is just commands that are wrapped with simple resource types with explicit task names. We do cover all the components necessary to install Kubernetes. That's etcd, Kubernetes itself, Docker, optionally Rocket as a container engine for the base services, kubelet, etcd, that is. We do major OSs, so that's CentOS, RHEL, Ubuntu, Debian, and CoreOS. And Cargo works great for deploying on bare metal, cloud, VMs, and so on. Well, I guess not so on, because those are the 3 options. So, as I said before, it's Ansible, cross-platform. You can even have heterogeneous nodes running different OSs. That's fine. All the components are containerized. There is no just single binary. It's just running systemd units. Everything runs with a Docker run command, or optionally Rocket. There's only one host package to manage. It's Docker. And with CoreOS, you don't even manage Docker. It's built into the OS, so it's the simplest OS to deploy on. Here's a bit of our compatibility matrix. Shows where we can deploy on. Everything in gray is items that are proposed or in progress. Yeah, so we Flannel, Calico, Canal right now are the network plugins you can use. It's not here, but also we deploy on the native cloud provider. So Amazon, for example, has a native cloud provider for Kubernetes. So why did we choose to work on Ansible? My team specifically. Well, we know Ansible scales very well, and it's very easy to write in. Mm, it's compatible with licensing requirements for most companies. It's free, very active community, frequent releases. So it's overall it's a pretty popular tool out there. It does dependency management pretty well as well. In each part of of cargo is broken down into roles, so you can choose which roles you want to use for each host. It's pretty simple. I can show a bit after the slides how the roles are broken down. This slide has a lot of text, but that's the entire installation. It's like a pre-install stage where we kind of calculate, okay, where's all the etcd endpoints, and so on. You know, what are all the IPs required for the deployment? What are their host names? You know, fill up Etsy hosts so all the hosts can resolve each other. And then we do some cloud preparation if necessary. Like there's some sysctl rules that are set up on Azure and on GCE that kind of are meant to protect you, but really they get in the way of Kubernetes, so we have to override them. And then install Docker, set up certificates, set up etcd, set up the masters, then the minions, and then add-ons. Add-ons, it's kind of a gray area. By default, all we deploy is DNS, and that's it. But in CI, we also deploy Network Checker, which sets up regular pods and hosts network pods that, you know, so they're daemon sets that run one on each host, and they try to ping every other available pod just to make sure we have full mesh connectivity. There's not many tools out there that do that so concisely. It's something this team at Mirantis did. Alexander Denko runs that team. He's an active contributor to Cargo as well. Oh, and the reason we do this network check is because during early steps of deployment, there were certain things that kind of broke things, like bridge net filtering in libvirt networks, for example. But these issues happen on different cloud providers. You have to make sure that, you know, encapsulated traffic can travel properly throughout your cloud. So that just is something to look out for, and it's good to use. Have a generic tool that works on every provider, and this could work on any Kubernetes cluster. It's not specific to Cargo. So one other thing that sets Cargo apart from some of the other tools out there is that it does support upgrades. We have supported upgrades since the Cargo tag 201. That's since December. We officially certified that Cargo upgrades from every release. From every release from 201 till current master. So you can, you know, be assured if you deployed, you know, several months ago, you can, you know, just check out the latest master, apply Ansible, and be reasonably confident it's going to work. It'll upgrade Kubernetes, etcd, regenerate certificates if they need to be, everything. So it is a comprehensive upgrade. And each component gets upgraded by just applying new config, updating the Docker image if necessary, restarting that component. If that component's a static pod, it'll just get restarted on its own. So upgrades are not so safe by default if you use the default playbook. So there's a separate playbook called upgradecluster.yaml. It can be used for new nodes, but it's much slower. It does them in batches so that you can cordon and then drain certain nodes, run the upgrade on those hosts, and then move to the next group. And as well, master nodes are done one at a time. That way you don't lose quorum in etcd, you don't have all your API servers go down, which would cause problems. But in a vacuum with no real workloads, you can use the regular playbook to upgrade. There's a chance your pods will get rescheduled, but as long as kubelet doesn't go down for more than a couple of minutes, it's fine. So theoretically it works, but really in production you should use the safe upgrade cluster playbook we have in Cargo. So Cargo has high availability. There's only two components really that need to be accessible by clients. One's etcd. It's a cluster. We prefer you have 3 nodes. It should be an odd number because of how Quorum works. Each client just connects to every etcd host with a common separated list. We have end-to-end TLS with separate certs for each host, client certs for each host. And the API server, we do a bit of an unorthodox approach. You can have your own load balancer and configure it within Cargo, but the default approach is that the masters just connect to localhost, and non-master hosts, minions, have a static pod that runs Nginx that does its TCP pass-through, and that Nginx forwards traffic onto the API servers. It's a little bit more expensive than having a dedicated API server, but it doesn't require having a dedicated virtual IP or managing it. So in production, you probably want your own load balancer, but in a dev environment, you don't have to do extra IP management, and this ends up working out pretty well for people. Moving on, Cargo is tested at scale, so we have done 1,000 bare metal nodes. It does take some time to deploy, so it's not a lightning fast bullet, but it does work. It can be done less than a day for sure. Since it's Ansible, all you have to do is update your inventory and you can add more nodes and redeploy. You can also use the limit option to specify which hosts you want to target. You don't have to update existing hosts. But you do need to have cache, so to know some basic facts about your existing hosts. In order to use that functionality. It's documented in the Cargo docs. You can combine all the roles. You can have an all-in-one cluster if you want, or you want to separate etcd from the master and then running workloads with master or not. We do that with the option of setting the schedulable flag in kubelet for standalone masters. This is items I've already talked about. Flexible DNS means we have just the vanilla kubedns that ships with Kubernetes, but we also have a slightly more tuned DNS mask that runs in front of kubedns. This will filter out bogus domains that can't possibly exist. A lot of people rely on search domains, and those force clients to try to look up certain domain combinations that just can't exist. So this really reduces a lot of erroneous queries. But we decided not to retune kubedns and instead set a second layer. It doesn't add really overhead, but it kind of keeps the complexity down. And so I've kind of raced through this, but the next item is just what kind of is on our roadmap. We do want to integrate with kubeadm. kubeadm now has support for phases. Phases means you can do just set up kubeconfig, just configure kubelet, just generate certificates or fetch a certificate for a given node. So these items are nice, and it allows you to kind of adopt different parts of kubeadm piecemeal as you want, rather than all or nothing. Other items that are really desirable from our user base is to improve AWS support for doing shared storage on AWS and using their load balancer and so on, rather than having to set up your own for API server connectivity. We have a contributed playbook for GlusterFS, and there's reports that Ceph just works. If you have an existing Ceph cluster, you can just drop in the storage config and it works, but we don't have anything really documented inside the repo. A lot of people who use the popular deployers really want to run end-to-end conformance tests, because the most basic deployment tools may not be convenient for their patches they're testing. If you need multi-node, Cargo is one of the best options out there, especially because it works everywhere. So it brings me to the last point. We're definitely looking for more contributors to Cargo. It's a promising project. It's incubated. We have sponsorship from Google for running CI. We have a really extensive CI. I didn't mention that, but we do test a variety of combinations of deployment there. The project page is here. We're in Kubernetes Slack and Pound Cargo. Check it out. Okay, so I do have a recorded demo. It's already deployed. I didn't want to waste time here showing you guys how Ansible works, but I will show you how Ansible works. Hold on, let me change the share. Not that one. Hold on. That one. You can see this terminal, right? Tomasz, can you see my one?
Yeah, we can, yes.
Okay. No, I wanted the recording, not this one. I am prepared, I promise. Yeah,
there was a very short notice, so
yeah,
you're absolutely
okay.
Good.
So this is a copy of what we do for CI. This is not bare metal, so this is quite inappropriate for SIG On-Prem, but it is a recording where we do on-prem. We use Ansible to create instances in GCE. We use GCE because Google gives us credit to test there. So we set up instances with the standard size, with 2 vCPUs and 4 gigs of memory, I believe. But you can get by on as little as 1.8. So deployment gets started with SSH. I'll show you there's a whole bunch of information gathering where we try to see you running resolve conf service. What are your name servers that are already on the host? Did you set a cloud provider and so on? And create some directories. This is an Ubuntu deployment, not a CoreOS. So in this case, installs Python apt, which I think is just for checking some repository configuration. We don't actually change anything. There's some tricks that get done. We disable IPv6 lookups because in some environments you can't resolve gcr.io to pull down official Docker containers. Oh, yeah, we use Python apt to configure the Docker repo, actually. That's what it's for. So it installs Docker. We default to 113, even though the latest supported one is 112. You can configure that and specify that. Oh, Thomas, you did ask, do we rely on system packages? We do. So Docker is managed by Cargo, except in CoreOS scenario, because CoreOS should have it pre-installed. This is it skipping through a section called Vault, where it does, you can use HashiCorp's Vault to generate and store certificates and then distribute them through its end, but it's not enabled by default in this deployment. Ansible just evaluates those tests and skips over them. Here, it's pulling down etcd container. So we run every service right out of a Docker container. Cargo tries to conserve bandwidth by only downloading containers on the first master, and then Docker save them out, rsync them to the others, and then load them back in with Docker. Hold on a second. Sorry. Now it's generating certificates. I'll skip ahead here. So it's setting up etcd. It does them all in parallel. So there's no setting up one host and then the others in sequence. It's all simultaneous, unlike some other deployment tools. And that's one of the strengths of Ansible. Moving down, we use Hypercube, not individual binaries or explicit Hypercube binary. It's a container. We use the Quay.io CoreOS one, mostly because it's running in Debian and it's easier to debug, but the official Google one works just as well, so there's no reason you can't use that if you prefer it. See here, it's rsyncing Hypercube. It's kind of a large binary now, so it takes some time. Moving down the line, we set up kubelet first and kubeproxy. Kubeproxy will crash restart until the API server's up, which is okay. It just creates some static in the logs. We generate certificates, one API server certificate, one admin certificate that gets used for kube config, on masters, and then one per host for kubelet itself. We do a Docker pull explicitly of all the containers. That way it's more obvious when there's issues pulling containers that there's a problem with the Docker pulling it, rather than it silently failing to start and then having to dig through logs later. I'll move a little bit further ahead. We also install the CA cert that we generate into the system CA. That way commands work natively. You can actually open up the dashboard and stuff with curl without ignoring the invalid certificate. Moving down, we do the same with Calico. Calico runs the system D daemon. The same, that only applies for Calico. We run Weave and Flannel and Canal all inside of Kubernetes as a daemon set. They're all upgradable either way. Calico, though, as a daemon set, can't survive upgrades that are slow, so we're still doing that right now as a system D daemon set. Move down a little bit. Set up CNI after we turned on Calico. A little further. we set up kubectl and its bash completion. Just copying the file right out of the hypercube container. After setting up each of the static files for the master, the kubeepi server, scheduler, and control manager, we wait for them to be up just in case something that follows needs to access it right away. It does slow down deployment a little bit, but we avoid race conditions that way. There's support for Calico Policy Controller if you want to use that, as well as Calico Route Reflector. Calico at scale in a mesh, which is its default format, is quite inefficient, so the route reflector helps speed up reconvergence when a node goes down or changes the state. Here's DNS information. We have two modes for DNS. One is where, DNS for the host, where we configure the host to point to the DNS and set some DH client preferences. That's one route. And the other route is where we directly inject DNS preferences to Docker daemon and have the containers get their information that way. Both options work, but the first option is vulnerable to other services that touch etcresolve.conf. Okay, yeah, thanks, Thomas. I'll stop the recording to show that we have the nodes up. This is two masters, one minion. Show that we have a etcd host. Each node gets each etcd role host gets different container. I think I don't really need to go into too much detail how we do each etcd. Hold on a second. I'm not sharing my terminal. Hold on. There. We have an etcd controller running. Calico node is running here, and kubelet, and then everything else is internal to Kubernetes. You'll see in a default deployment, we get DNS mask and kubedns. There's Nginx proxy running just on the non-master node. And our default services are DNS mask, kubedns, the default Kubernetes API, and then the net checker. And the net checker is just for showing connectivity, and it reports, did all the hosts check in, and did they report any issues connecting to other hosts? Let's see. I think that's all I really wanted to cover. I think we can go to questions now.
Yeah, great. Thanks. So I have a quick question. So you didn't mention who's contributing to Cargo. I mean, what companies, what the development looks like now?
Well, there's Marantis. There's the project was started by a pair of French gentlemen who now don't work for those companies. One now works at CoreWest and the other Dailymotion, but that's not related to their contribution to Cargo. Some people from Dell, Intel, RackN. It's really, really diverse. There's no single company that really drives Cargo development right now.
All right. Oh yeah, we have Rob here as well. Yeah. Okay. Cool. Any other questions, guys?
Does it work offline? So if there's no internet connectivity?
So
can you specify where to grab all the containers and all the water finders?
So there's two parts that come from external sources. One is Docker containers, and the second is Docker itself. So if you reconfigure the Docker repo or pre-install Docker, you're fine on that end. And the second end is there's, I can show you here. There's repository. So there's these sources for all of the containers, which is, we pull from Quay.io, but you can just have some hosts, Docker pull, and then push it to a local registry, and then just update your config with your registry here. And then it'll deploy from there. And that's actually recommended strongly at scale.
Cool.
Any other questions? Yeah, I don't expect Rob to have questions, but other guys, Justin.
So let's say 10 node cluster. How long will it take to bootstrap it with Cargo?
10 nodes, I would say about 20-25 minutes.
Okay. Is the main issue like just the speed at which Ansible operates, or is the just installs and pulling down all the containers? Do you have like a breakdown where it takes the longest?
I will admit there is a breakdown, and part of it is the number of tasks there are and how many things we check. So that just churning Ansible and evaluating things is about a third of the time. Another third is pulling Docker containers. And the rest is actual work, like it's changing file config, starting things, waiting for them to be ready. If you kind of just splashed it all together and started it on without checking, it could be faster, but it's better to be sure that it's up than how to stay set it up and pray.
Cheers.
All right, great. So if there are no other questions, let's go to the another point. So Matthew, thank you very much. So again, Cargo is looking for contributors. I tried to. Can I stop your share, Matthew?
I can.
I mean, may I? I'll do.
I stopped it.
Okay. So back to the agenda. So next point at the, oh Jesus, that's a lot of notes here. Thank you, Marcus. So Jorge suggested to eventually start fixing the documentation on premise. So this is how it looks now. The bare metal choices. So definitely. There's a lot of choices, I would say, and we would like to take it and make some more structure here, etc. So is anyone actually interested in doing this work? I think I can start with some basic structure for the next meeting, and we will be probably looking for some volunteers to do this work. So anyone interested in this, really?
Yeah, this is Joe Kaiser. Sorry I'm late. I'm happy to do some of this work. When I was doing our own implementation with CentOS in particular, I found some of it useful and a lot of it out of date. So I'm more than happy to start working on some of the things that get more up to date and usable for people.
All right.
So I'm happy to write.
That's great.
I have an existing pull request for removing the CentOS documentation because it is so out of date. I think that's still on Kubernetes 1.3 or something.
All right.
It's old.
Yes. So yeah, I have a pull request to remove it, but there are like 4 steps they want to take for anything that we want to remove completely. It has to go through like a couple months of deprecation. And so I haven't put in that effort because I just haven't had time anymore. But yeah, there's definitely some cleanup that needs to be done. And things like, there's 3 Fedora ways to install it. And it's like, well, maybe those can be consolidated or, I don't even see like kubeadmin on this list. And that's more of a universal way to do it. And so
So when I was like looking for this info, like people would just tell me like go use Kelsey's Kubernetes the hard way, or try to figure out how to do the kubeadmin way. And I was like, yeah, that's not optimal.
Yeah, so I know that KubeAd has its own section on documentation. I'm not sure how much it covers the bare metal and how much it differs from other platform. I remember when I was going through the Kubernetes hard way, I was essentially unable to do it on bare metal really. So I was just checking. Okay, so it looks like there is a need for that. So I was not able to talk to Jorge, but I think we'll prepare some plan and send it over to the mailing list and discuss it there. And once we have a plan, we can start asking for some commitments, maybe some sections, etc. But do you guys have some ideas how it should be structured? I really don't like what is there now. I mean,
Yeah.
I'm just, how people start. I mean, do people start with the distro or do people start from some other point, or how does it really work? I'm not sure.
I think it depends on whether you're kicking the tires or you're actually having to deploy something for dev, test, or prod. I think that if you're just kicking the tires, you're going to find whatever, 4 or 5 machines you've got and start playing with things and seeing if you can get it up. And I think that if you have to actually deploy something, that you start with some kind of system for making sure that all your machines are relatively robust and consistent before you start going at it.
Yeah, but I'm more asking, where people, when you're starting to look for documentation, where do you go? I mean, would you start with the distro section, or would you start in some other section, or just general bare metal considerations, etc.?
When I started with bare metal, I went to this bare metal section,
which is very bad.
Yeah.
which a year and a half ago was fine because it was useful, and a year and a half later, it was absolutely not useful at all.
All right. So then, what would be your next step? So you're here and you're looking for what? So you would start with the distro, or you would start, I don't know, with the deployment method, or?
I would start with the distro.
Yeah.
Sort of interruption. Yeah.
Yeah, I agree.
Well, I would start with cross distro things like Cargo and the things that work on multiple first, because those are probably better supported and can go, it doesn't matter what distro you're on, it'll support, the major 5 or something like that.
But again, you're looking at the distro description for Cargo, for example, and if it supports your specific distro, you will start working with it. So we're not speaking about the distro itself, but about the concept, the idea. So what is the bullet point it's showing for you at first? So I suppose that's distro question.
Would it make sense
sorry, please continue.
Would it make sense to cut bare metal into 2 headings, essentially distro specific and then multi-distro?
I think it will help to just have a matrix, like which main OSs does this tool support, and does it work offline and online, and what other queries it needs. Most of the issues that I find with bare metal is that this offline, it doesn't work offline. So.
All right. So
the main reason people want to stick with the distro usually is just familiarity or policy. As far as I can tell. I mean, once you have Kubernetes installed, what does the distro matter? Hopefully you never interact with the OS again.
Yeah.
And so, I mean, it's only a.
I think one of the reasons that they're organized by distro is purely accidental. When I was adding the CoreOS docs, there was a lot of pre-existing stuff, and the CoreOS name was the only one that we could legitimately claim.
Yeah.
So all the recommendations, it just links out to the CoreOS site, and I think some other distros have done it too. Because with all the other things in there, it's hard to know where to put your stuff.
In a way, it depends how far we want to go with this installation on bare metal. They also cover basic sysadmin tasks like kickstart and building from Pixie boot? Like, can you have a Pixie boot solution that will just go and set up Kubernetes for you? Like
we had this discussion, and essentially, I think most people agreed that we should not go into that. I know that it's sometimes somehow ignored a little bit, right? It's like, take care of it before. But I think there's so many solutions that it would be very hard to agree on some standard here, right? And at the same time, if we just take the cargo docs, it will essentially mean copying the cargo docs here. So it would need to be more specific for on-premise stuff. All right, I think it's a good start. I will talk to the docs team. Maybe they have some ideas, and I will talk to Jorge and post some email to the mailing list, and we can discuss it there. But yeah, definitely this is something we need to fix here, because it makes the impression that on-premise Kubernetes is really hard. It's looks like early days of Linux. Yeah, go ahead. All right. Yeah, I think we're running out of time. So the last thing on the agenda is actually SIG leadership. So I'm not sure if we'll be able to finish this here. Probably not, because I will need some more transparency. So this will need to go through the mailing list. But so Joseph Jacks, who initially started the SIG, well, in fact, he moved out of Kubernetes. I spoke to him on KubeCon, but he's working in the company when he just simply cannot devote too much time to Kubernetes. And this makes running the SIG extremely challenging. It just turned out that one person is just not enough to run a SIG. And we also would like to have some more diversity and have people really engaged in running Kubernetes on premise to help here. So we're essentially looking for more leads for leading the SIG. There's some more ideas, etc. Well, essentially, even if we focus on the initial ideas, that would be great. It's just the execution side that is not working optimally now. So again, I think because some people, well, Dalton is actually here, but there were also people from Canonical and I think other companies that initially promised that they would devote themselves and commit some time and help running the SIG. So I will post another email on the mailing list. We can discuss it there, but yeah, for all of you guys, something to think of if you can afford helping with the leadership here. So I also need to talk to Sarah, because it looks like there's no procedure for kind of doing the stuff like electing the SIG leads, etc. So I think we'll just rely on some agreement on the mailing list. So yeah, please think if you're interested in running the SIG and bringing your ideas. And again, it would be great to have someone that is really, working day to day, knows the community, knows the staff, the solutions, etc., etc. All right, I think that's it from the official agenda. So any other questions?
Just a quick one. Does anyone know of so all the SIGs and kind of projects have something like there is Minikube? What will be like the equivalent of a mini-prem?
Minikube works on prem, right? But you want to have like a minimal deployment on physical machines, right? Or
yeah, like a reference deployment, essentially.
I'm not aware of such thing, but
This was one thing we tried to create with CoreOS Matchbox, was a local environment that simulated bare metal as closely as possible. And it's,
all right. Okay.
It's a bunch of new KVM machines which are distributed.
Yeah, but it's not on-prem. It's VMs, right?
Yes, but they're set up in a way to mirror that as closely as possible. If you are wanting a small version of on-prem, then I can't help you with that.
Oh, cool. That will be cool. So
It's a
what does,
local version.
so Dalton, what does it really mean that it's close to on-prem? Like you use some, like, it's hard to imagine for me. Well, so technically,
So that means on your Linux machine, you have a QEMU KVM install, and there's a virtual bridge that runs, Rocket runs or Docker runs some network services like your DHCP server, your DNS server, a Matchbox server. It creates an isolated little environment where you can test out different components.
oh, that's great.
If you want to run like a Squid proxy on there, if you want to run like some other component, like set up Vault or any other component that you would normally set up on premise, and then you just power on the VMs that are attached to that network and see what happens. So in our case, we try to bring them up into a whole cluster.
Oh, so it's like a data center in a box, right? A little bit.
Sure.
I was thinking maybe something like Intel NUX instructions, or maybe like a provider. So like we have AWS, Google, but none of them provide bare metal. So like a bare metal provider like OVH or Say Start or Hertzner.
Oh, that's actually
Between OVH or Intel NUX.
So OVH and Hertzner are providers of bare metal servers essentially.
So you're looking more for a reference implementation on a specific piece of hardware or a cloud provider's hardware.
Yeah, so something like not essentially Google or AWS, but for on-prem.
Like
Because
Packet
you can buy on-prem clouds from providers. Or just buy a bunch of Intel NUCs, which are small servers for £200 or something, and connect them together. And what would you need?
Yeah, I don't think there's such thing. So I think there's more problems with that approach. Like, we don't even have a standardized way for many things that you're getting on the cloud just out of the box, like, DNS stuff, like, I don't know, load balancers, global load balancers, this kind of stuff. So we had a discussion about actually a very simple thing, which is exposing your workloads to the outside world, and it looks like people are doing this in very different ways. So I think this is a problem here as well, that there is no standard for on-prem.
The other issue I found when I was running an Intel NUC cluster to start developing on Matchbox a year and a half ago was that it wasn't similar enough to production. They lacked VMCs, and that was part of the way that we wanted to manage those machines in an automated way. So even Intel NUCs sort of fell short, and we ended up using real hardware, like a real on-premise set of machines that we have at the office. So I don't know what to do there exactly.
Yeah.
Seems like Packet or OVH could be an option if people wanted a reference implementation. And I guess the NUCs are plenty for learning.
So I think Ubuntu did something with NUCs. Like they have a DI bare metal cloud with GPU clusters.
Yeah, it's definitely possible.
They have this Orange Box, but that is like their personal solution.
Yeah.
Metal as a service.
Yeah, that's an interesting problem. Yeah. So, the question is that do you know if any of the big, let's say, hosters provide Kubernetes? Like they provide, I don't know, OpenStack. Or you click and go, and you have a bare metal OpenStack in like an hour or something. Is there such service for Kubernetes already?
Packet a little bit, but I think it's through some partnership type of thing, so it's not really directly obvious from the website.
Yeah, they allow you to deploy CoreOS, as far as I remember, CoreOS with Kubernetes on top. So OVH doesn't allow you to do that.
Okay.
They have some OpenStack related services, but not Kubernetes.
Yeah,
the same as for Hetzner.
You can deploy on OVH CoreOS, and you can have a VRAC to like simulate the VLANs. But that's about it as far as it goes. I don't think you can Pixie boot.
Yeah. Okay, that might be something interesting to maybe attract the OVH guys or someone like that to help with that. Yeah, maybe. Yeah, I try to think about how we can get to those guys and maybe get some attention from them for the bare metal.
Joseph Jax is collecting the spreadsheet for Kubernetes community and CNCF, where he tracks all the possible distributions of Kubernetes in multiple ways. So probably may reach him directly or simply read the spreadsheet and find. Probably there is some possible solution for us.
So if you find it, that would be great to put it in the notes here.
Okay.
Okay.
I will put the link to the spreadsheet itself and that we may discuss.
Yeah.
What's the demo we have next week?
Not next week. In 2 weeks, we'll most probably will have OpenShift finally. So I hope so. So I'm in contact with Red Hat folks. So Clayton.
Okay, I can do. Whenever there's a free slot, I can do the CoreOS demo.
Oh, that's great. Okay. I will take note for that, definitely. Yeah, so let's see if the guy is happy with the next meeting. If not, I will let you know that you can jump in and do the demo. That will be great.
Sounds great.
All right. Yeah, we're out of time, actually. So thanks, everyone. And see you in 2 weeks. And yeah, I'll send those emails to the mailing list, so please respond and take part in the discussion.
Could you also post a link to the recording too? I missed the cargo demo and I'd really like to see it.
Yeah, sure. Yeah. So there's this. Yeah, I will share there's this playlist on the Kubernetes channel that you can use. But I will share.
Oh, okay. Cool.
Yeah.
Thank you.
Okay. Thank you, everyone. Have a nice day or have a nice evening. It depends on the time. And see you in 2 weeks.
Great.
Cheers,
Thank you.
Thank you. Bye.
Bye.